Good morning, everybody. My name is Richard Stratton. I'm the Managing Director of Cundall's MENA business, and I'm very grateful to those that have joined our World Green Building Week event called Triage for an Ailing Planet this morning. I'm going to do a brief introduction and then I'll hand over to a colleague of mine. So as part of the World Green Building Council's theme of Act on Climate and how we prioritise and decarbon the whole built environment, we're running this event across the globe. As everybody knows, we're in a climate emergency at the moment and have been for some time. The human impact on our planet has been and is devastating and needs urgent attention. The built environment has a major responsibility to decarbonise, but with an overwhelming need which is greater than supply of resources, it's difficult to know where to start. For World Green Building Week 2020, Cundall's sustainability experts will discuss how we can act on climate by setting effective pathways for existing assets and portfolios and advising on which priorities to action for the greatest impact for the race towards zero carbon. They will look at how we can make existing buildings net zero carbon, reduce operating costs, improve occupant comfort, and increase asset value, using tools and examples to show how we can make existing buildings 70 to 80% more efficient. Putting it in a regional context, the UAE, Qatar, Saudi, there's a variety of commitments that have been made over the last year, whether it be the UAE National Climate Change Plan, Saudi National Vision 2030, or Qatar's commitment at the UN Summit last year, with the objective of making the FIFA 2022 World Cup the first zero carbon or carbon neutral championship. Is this enough? Now, Alan Fogarty, who's one of my business partners at Cundall, and he's a head of sustainability and heads up our group in the UK and MENA. He's going to discuss these points. Specialising in low energy and sustainable design. Alan's been in the business for 30 odd years. He's a building services engineer by training, and he's gained extensive knowledge of natural ventilation design, passive design techniques, and assessments of renewable energy, natural lighting, and a whole variety of sustainable initiatives within the built environment. He has also developed specialist fields of competency in chilled ceiling systems, passive cooling systems, and is an expert in UK's building regulations, Part L and BREEAM, as well as being intimately familiar with most of the sustainability systems we use in the region, whether it be LEED, Estidama, and so on. So Alan has previously worked in Australia, so he's experienced the whole sustainability debate and development globally. And as I say, he's been with Cundall since 1999 and been leading on sustainability since then. So without spending too much more time on the introduction, I'm going to now hand over to Alan to take you through the presentation, and I hope you all enjoy it. And if you have any questions, just ask them on the Q&A section of the Zoom, and we'll deal with them as we go. Over to you, Alan.
Thank you, Richard. Good morning all, and welcome to the first presentation on behalf of Cundall for World Green Building Week. Just a couple of slides about Cundall. We're an international engineering consultancy. We've been going since 1976. We have 25 offices globally. We're an award-winning business, and one of the key elements to Cundall is that we are very committed to sustainability. We're a one planet living company, which means we basically practice what we preach. And this is just showing our locations around the world. So we've offices over in Australia, Singapore, Hong Kong, China, Middle East, in Doha and Qatar. And our main offices are in the UK, but we've also got offices in Madrid, Warsaw, and Bucharest. We've got a very wide range of engineering services, so our core disciplines are building services, structures and civil. We've got a whole range of specialities around that to support those activities between acoustics, fire, security. Sustainability is something that we drive through all aspects of the business, but we're quite specialised in that as well. And we work in all sectors: aviation, critical systems. Critical systems is a very key element for us, and it's a very much an international offering, working for groups like Facebook, Microsoft, right around the world. Education is a particular strength of myself, and we do all the other main elements: retail, residential, etc. So straight into the presentation. So the focus very much is about net zero carbon, and I've heard more around net zero carbon in the last 12 months than I've heard in the last 20 years. It's become a really major consideration in many countries around the world. And the fact that countries are recognizing that there is a climate emergency, it's recognizing the fact that we've had some fairly extreme weather events in the last 5 to 10 years, between flash flooding, extreme temperatures, particularly in the last few years. And the contrast to flash flooding then is water stress. So we've had droughts. And in the last 4 weeks, in the last 6 months, we've seen wildfires in the US and in Australia. And climate change has been recognized as one of the contributors to those particular events. We've also seen demonstrations right around the world, and these demonstrations have been responded to by many organizations with a need to do something different. We have clients who have seen these people demonstrating into their streets, and they've realized that they haven't been doing enough, and they have very quickly been getting themselves organized so that they can get policies in place so that they can start dealing with some of these issues. So there's a groundswell of concern among young people in particular. And when you look at where the source of carbon emissions, we can see that the building stock is a major contributor to that. So the actual operation of buildings contributes about 28% to the carbon emissions. Building materials and construction is around 11%, so it's 39% of the total, which is quite a substantial contribution. And obviously transportation, then getting to and from buildings, homes, etc., is a major contributor as well. So all these various aspects have to be dissected and addressed. And in the UK in particular, we're seeing pressure from the top. So the government has committed the UK to being zero carbon by 2050. And that commitment was made a year ago. It's legally binding, and effectively organizations, public bodies are all looking at plans for how they would actually go about getting to zero carbon. I am currently working on what's called Gen Zero for the Department of Education, where we are developing plans for zero carbon school prototypes, with the intention that all schools going forward will be designed to a zero carbon standard. So this is going right through the country, and it's not just the UK. There's many countries around the world now that are looking to adopt these as legal binding requirements. There's also quite a push from investors, so they are looking for organizations that have taken a strong environmental stance to invest in. We work for various American funds that are looking at assets that are potentially able to be improved environmentally, but also provides a social value, and they are buying assets right across Europe and the world. Developers are committed to the World Green Building Council's net zero carbon commitments. We had a presentation last March with the Emirates Green Building Council specifically on this very element. So right around the world, all the green building groups are taking up this challenge, and we would very much recommend that you support the Emirates Green Building Council in their efforts to achieve these commitments. And then there's occupiers as well. So companies are recognizing the fact that they need to do something specifically, and they are adopting science-based targets, which effectively would deliver the Paris Protocol. And it's looking at all the activities of a company, from flights, travel, what they consume within their buildings, and working out suitable targets to be able to achieve the climate change targets of the Paris Agreement. So just focusing specifically on net zero carbon buildings. So we've looked at this, and this is kind of showing the breakdown. As we said, it's almost 40% the actual CO2 emissions associated with buildings themselves. And so we as an industry really do have to take on board the carbon reduction strategies in order to be able to achieve the world targets. So the World Green Building Council has set out various targets, and for new buildings, by 2030, we need to achieve a net zero carbon in operation standard. For existing buildings, the target is for 2050, recognizing that existing buildings are more difficult to deal with and need more time to get the retrofits in place, and we'll discuss both those areas over the next few slides. So when you look at a net zero carbon building, the first element is net zero carbon in construction. So it's looking at all the elements that go into constructing the building itself, structure, facades, etc. The other element is the operational energy, so the energy consumed by the building through heating, lighting, appliances, etc. But when you look at whole zero carbon whole life, it has a range of other things which aren't specifically included in that definition. So it's maintenance, demolition, and reuse at the end of the life of the building. These are quite difficult to deal with at this point in time, simply because we don't know specifically how the building will be recycled at the end of its life. And the best strategy for some of these things is for the building to be designed for recycling, so that you recover that asset and the financial value of it at the end. And the fundamental principle is that we need to reduce the energy intensity of buildings and increase the amount of renewable energy being generated. And the two will meet each other at a point, hopefully before 2050, if all goes well. And at that point, then we are producing sufficient amount of renewable energy to satisfy the energy intensity of future buildings. Now, this is a set of targets. It's UK specific, but it shows the kind of principles of what is trying to be achieved. So currently in the UK, you could say that the energy intensity would be anywhere between 200 and 160. In the Middle East, due to the higher cooling demands, I would expect the energy to be around 200, 250. But the point being, though, we're trying to get from 160 down to 70, which is a very, very significant challenge. That's for the whole building. You look at the very bottom line, it's suggesting what the energy intensity for tenants are, and that'll be similar right around the world. So currently, on average, we're probably around 70 kilowatt hours per meter squared, and we need to have that. So what does that mean for businesses working in businesses? They need to think about the servers that they have, which consume a lot of energy and require cooling. So by transporting those to cloud services means you take that energy out of the building and the cooling requirements, and that makes a significant difference. But it's also how people manage themselves in buildings, making sure lights are turned off, and that equipment is shut off at the end of the day. All are really important. Getting to these targets is going to be very difficult. It will require a lot of effort from a lot of people. The RIBA have similar targets, and you can see for 2030, they're suggesting a range of between 0 and 55. Well, 0 clearly is not possible, otherwise buildings are no longer of any use to anybody at all, but certainly 55 is the demanding target. There's also targets for embodied energy, the suggestion being that we're about 1,100 now, and we need to get down to 500 500 currently is hugely challenging. That would be a timber construction, and that involves technical difficulty and cost. And these principles of embodied carbon are certainly being adopted locally. So the suggestion is that there's going to be 40% less embodied carbon in the Emirates by 2030, and zero carbon embodied carbon by 2050. So it's a similar type of trajectory that's been suggested right around the world, and it's the same challenge in every region. So just looking at our framework for zero carbon, so we've looked at what are the various steps that one needs to take to get to zero carbon. And the first aspect being passive design, so get the basics right within the design itself, reducing operational energy demand and consumption, eliminate or minimize fossil fuels in buildings, looking at renewable generation on site and storage where possible, and there's obviously limitations with that, limiting the upfront embodied carbon, which I'll talk a little bit more about. Consider whole life carbon in conjunction with whole life costing. So cost is a resource for a project. It needs to be considered in conjunction with carbon so that you get the maximum carbon benefit. And then transparency, so public disclosure of the actual performance of a building, so you can demonstrate to other organizations that it is possible, and encouraging them to do the same thing. But the word optimization is a tricky word in the sense that we always talk about optimization of buildings, building facades and so on. So how often can you optimize and actually achieve something different? So that needs to be looked at much more carefully. So when you think of the first step, passive building design, where do you start? Well, one of the key elements is the envelope itself, and saying what's the maximum amount of glass that you need on the facade to get daylighting in. The glazing is a source of solar gain, it's a source of heat or loss of heat depending where you are in the world. Either way, it's a weak spot for the building. So you shouldn't have any more glass on your building than you absolutely need for daylighting. And the way to work that out would be to look at metrics such as useful daylight index, which basically is looking to get only as much glass on the facade that provides useful daylight. And that way you can minimize the glass on the facades without compromising the daylighting of the space. The next step is looking at the envelope, having the right levels of insulation to keep the heat out, designing out thermal bridges, which are weak points in the envelope, which will allow heat to move into the building itself. Natural ventilation is definitely an option right around the world. Even in the Middle East, there's times of the year, 3 months or so, where natural ventilation would be very effective. We have integrated natural ventilation into a number of projects, including the American University, Shara, and that's proved to have relatively low energy consumption. It's down as low as 150 kilowatt hours per meter squared, which is pretty good for the Middle East in particular. It effectively allows energy reduction for about 20% of the year, so it should not be ignored. The other aspect of facades is the infiltration levels, and like air leakage testing is a really good way of seeing whether the facades are achieving the standard that's required. Not achieving the standards means then you're going to have problems with condensation within the building, and with that you've got mold growth on ceramics, ceilings, etc., which is also bad for people's health. So some of these photographs are from colleagues' houses and workplaces, there's lots of good reasons for making sure that we have decent standards in buildings. Reducing operational energy demand and consumption is one of the next steps. And there's a whole range of things of building optimization, systems optimization that can be looked at. But in doing so, we need to make sure that we're looking at energy carefully from the very early stages of the design. And one methodology for doing that in the UK is called Design for Performance. It's coming from an Australian system called Neighbours. And the idea being that you are looking at proper energy models that accurately reflect the building performance and reflect the actual makeup of the systems themselves. So you're building plant models which have all the control strategies built into it, so you can effectively test drive the building at the design stage to see how the selected systems are performing against the variable loads within the building. This means you can then establish what targets are there for the building, and they can be included in contracts so that contractors are legally obliged to deliver those standards. And it's a way of actually testing whether the commissioning has been done properly and whether the building has been constructed properly. So in the first year, you can compare the actual energy consumption with the predicted energy from the simulation tool. And that highlights then which systems haven't been commissioned properly or not working effectively, and allows then an optimization process to occur. In Australia, this has reduced the landlord energy consumption by about 70% in offices over the last 20 years. So it's a system that is demonstrably effective. Minimizing fossil fuels, and again, there are a number of areas within the Middle East where cooling, heating is still an issue. So if we can get heating systems onto electric supplies using heat pumps, then as grids decarbonise, then by default the heating is dropping down. Using solar thermal, which is increasing in the Middle East, means then we're just using the energy from the sun to generate hot water for residential and other buildings. Photovoltaics are another methodology, and particularly with batteries, then we can match the generation with the demand. This is a development in Dubai which is looking to significantly reduce the carbon emissions of Dubai, and so far the photovoltaic element of the development has been installed, but there's plans for a concentrated solar installation, which is a means of generating energy by concentrating the solar onto the very top of these towers, which generates steam and allows them to function through the night. And it provides reliable and continuous electrical generation for the city. So this is part of the plans for Dubai to become the lowest carbon city in the world by 2050. So we've talked quite a bit about the operational side of things, but as the operational energy drops, then the embodied carbon going forward becomes the main source of carbon emissions from a building. And as a result, we do need to focus on the embodied carbon. And the embodied carbon is looking at the energy associated with the construction materials, right from the point when they are extracted from the ground through the manufacturing process, transportation to the site itself, the construction process, and then going through to demolition and operation. And this is kind of looking at a breakdown of the various materials in a building, and it shows in blue the steel has a very significant contribution to make. Concrete is also a very strong contributor in terms of CO2. And when you go to look at timber, which is in pink here, you can see the dramatic shift it has in relation to the overall embodied carbon of the building itself. So timber is certainly an option that needs to be considered, and see what contribution it can make to reducing embodied energy in buildings. There's methodologies for looking at the embodied energy of buildings, and RICS have set out whole life cycle assessments that can be used to guide people through it. There's various tools, and we created the CIC a tool for the Hong Kong government, which is available. But as I said earlier, considering whole life carbon in conjunction with whole life costing is really important. So we're working on a project at the moment where the client very much likes the idea of going to a CLT solution, and it has benefits in terms of low embodied carbon, but also it has a biophilic element to it. And so people very much like the connection with natural materials, and it looks fantastic. Concrete is the alternative, and it provides passive cooling, which is a good thing to do, and it's great from a perspective of acoustics, etc. So there's lots of good reasons for using concrete. But just looking at purely in terms of carbon emissions, one of the questions I've asked is, while the CLT is certainly a lower embodied material than the concrete, it also costs about 30% more. So the question I posed was, if you took that 30% cost difference and you invested it in something else in the building or outside the building, would you get a greater carbon reduction for your dollar compared to the timber? So you need to look at the financial resource in the project and see whether where you're investing it is giving you the best carbon reduction for your investment. And reporting, again, is very much about transparency, making sure that people are doing the right thing. And it's part of an overall strategy for any organization. So first point being that you calculate your overall carbon footprint, you try and reduce that to the minimum, and then where possible, you offset that. And all that needs to be a very transparent process so that you can see what's actually happening and that everybody understands where the carbon reduction is occurring. And offsetting is something that we need to be very careful about.
Alan,
yes.
Sorry, Alan, can I just we've had a question come through, which I think might be worth just asking at the moment. One of the questions has been, what are your thoughts on the gap between predicted and actual building energy consumption? Okay, Ross Garforth asked this, and he's saying his understanding is that there can be large gaps once the building has been handed over. And what is the industry doing to close the gaps? So there's a kind of a three-parter there.
Yeah, no, absolutely. Well, first of all, there has been massive gaps, and a lot of it is about the fact that the way tools have been used wasn't so much about prediction, it was more about compliance. So using tools to show compliance with building regulations, etc. So the tool itself wasn't even set up to provide accurate predictions. And we've had that particularly in the UK. So the numbers produced by these tools were about a quarter of the real numbers. And what they really were doing was just comparing the efficiency of the selected elements in the building with a standard. And one of the problems is energy in a building is consumed by the occupants themselves. So if you set up a tool that just models the building from 9 to 5, then you lose all the energy in the out of hours use, so at nighttime, weekends, etc., which can be considerable. And it also assumes perfect control, which is very, very unusual. And then the profiles are one size fits all, so it doesn't necessarily match what an organization is doing in that building. So that's been one of the first problems. And second of all, the use of the right software systems to emulate a real building hasn't been happening very much. As I said, Neighbours, the system used over in Australia, was one of the first attempts to do this, and they've been going at it for about 20 years now, and they've developed methodologies for accurately predicting energy consumption. And there's a robustness to it because you test various scenarios. So you look and see what happens if the building has twice the occupancy, half the occupancy, and how the systems respond to it. So when you then occupy the building, it's been stress tested in relation to the various ways that tenants can behave. So when you understand how tenants are working in the building, you can then compare it to what the predictions were suggesting, and they have proven themselves to be reliable and accurate predictions. So I think that answers the question. Was there anything else I missed?
Oh, I think the only thing I'd add to it, Alan, is, this is, my advice to any designer is you can design a building to be very low energy or zero carbon, but you always need to think about how that building is going to be used. Who are the users? And if you can design a highly efficient building that's used irresponsibly, and it won't perform. So you need to think about who's going to use it, and you need to think about either systems that can help them use the building more responsibly, but also through the operation. It's really important that the owner of the building, the user of the building, has a policy throughout the life cycle of the building to constantly assess performance, educate users, and drive improvement. I think that's, you got to remember, we're dealing with people and we're all different. So, and it's very, as Alan said, it's very difficult to predict how people will behave.
No, absolutely. So just moving on then, so the carbon offsetting is effectively investing in projects potentially around the world to reduce the carbon emissions associated with a particular development. I have to say I'm very nervous about offsetting. Like EasyJet were offering to offset the carbon for their flights at a cost of £1 per flight, which to my mind was too easy. And the United Nations produced a report a few years back which basically identified that 80% of the offsetting projects had little or no environmental benefit. And we can see the difficulty with some of these things. So for example, planting trees, you're not going to get any benefit if you have forest fires, as we have seen in the States and over in Australia. So your planted tree suddenly disappears and hasn't provided any carbon reduction. So really, in terms of offsetting, it's making sure that it's kind of gold standard offsets, so that it really is genuinely providing a carbon reduction. Ideally, make it as close as possible to you, so in the city, at the town that you're doing the development in, where possible. And an organisation could think about offsetting directly, so potentially going into a local school, upgrading the lighting there to LED lighting or some other element that's directly under their control, as opposed to handing money to somebody else to do the offsetting for them. And if you look at the offsets that are offered, if the cost is low, then it probably has very little genuine benefit. So you can get offsets for as low as $5 per ton, and the real carbon value is in excess of $80 a ton. So anything below that isn't necessarily providing the real value. So we've talked a bit about new build and some of the approaches to dealing with that, but actually a huge problem is existing assets, and their inefficiencies are already locked in. So somehow we need to go back into those buildings and be able to decarbonise them. So we've been working on a number of projects for clients, and they are looking very seriously at their portfolios. We've done a range of projects now where we've looked at retrofitting heat pumps into buildings to remove or reduce the use of the gas-fired boilers within the buildings themselves. And in particular circumstances, the energy equation can really stack up, because with the heat pumps, there's the opportunity for heat recovery. So you can take the heating from the cooling system, or the heat from the cooling system, and use it in the heating system when required. So some buildings that have high internal loads from, say, bankers, feeding floors, etc., that heat then can be reused in the building, and that has a significant benefit and helps pay for the potential additional costs associated with electricity. So just looking at how you would go about decarbonising a building. So typically buildings are up in excess of 200 kilowatt hours per metre squared per annum, and we're trying to get to 55, which is a very challenging target to get to. So this is looking at the steps. So heat pumps, as I mentioned, is one of the first things. That's removing the fossil fuel from the building, or at least reducing it. And that presents many challenges too, because you get rid of your gas-fired boilers, but then you suddenly have to generate all your heat from electricity. So is the electrical capacity of the building sufficient to supply that heat pump? And then if the envelope isn't significantly insulated and well sealed, then the amount of electrical energy you need is significant. So getting the fabric sorted out is also a very important element. Introducing natural ventilation, as I said earlier, is a great way of reducing the annual energy consumption. But again, that requires window replacement, access to facades, etc. It can be very disruptive to tenants. HVAC plant optimization can be done centrally, so that's less of an impact on tenants. And then finally, behavioural of the occupants themselves should be considered. So one way of thinking about it is that if we didn't cool buildings to as low a temperature as we do, and we allowed temperatures to rise, then the energy consumption significantly drops. What we don't want to do is provide uncomfortable environments for people. So again, if we are upgrading facades, we can look at less glass while still maintaining views and good levels of daylighting, which potentially means then that you could have higher temperatures in spaces without significantly causing discomfort. And we've seen from various activities, particularly through our work with the WELL building standard and the look of biophilia in buildings, that people respond very well to biophilic design, to a point where you can effectively distract them from levels of thermal discomfort for periods of time. So you could have an overall strategy for how you would allow buildings to operate at a lower level through occupant behaviour and biophilic responses without compromising productivity within the building itself. And all this needs to be planned out. As I said, you have occupants in buildings, you cannot disrupt them too much. So you need to look at central plant replacement and then work out what is the zero carbon roadmap for that building. It needs to be timed in when leases expire, and that allows then green leases to be put in place too, so you can get tenants to think about how they're actually going to behave within the buildings and come to an agreement as to what would be the operational profile, so that systems can be set up to respond to that. At some point, overcladding becomes a possibility, so then you can get green leases in place, etc. So all these steps need to be planned into the overall development. And you can see from this graph what's being planned on this particular building that we're looking at in London. And there's no silver bullet. It's a question of incremental improvements so that you eventually then get to that zero carbon target. That's the end of the presentation. Thank you very much for listening. If you have any questions now, and if any questions that come through on the chat, Richard will relay them, and I'll do my best to answer them.
Well, I've got a couple. So question is, in order to get the necessary traction to encourage net zero developments, what do you believe the key changes that need to be implemented are?
Well, I think the positives need to be brought out, and there's a number of positives. So if you look at it from the perspective of whole life cost, you are reducing the waste of energy in buildings. And so while there's an increase in terms of capital cost, there is also an energy saving which will pay for that capital cost. And what I would say, and what I alluded to earlier, is that one of the biggest savings in a building is getting systems set up correctly. And when systems aren't set up correctly, they have negative impacts on the people in buildings. So if you looked at a building and there was a problem in relation to the energy consumption, there's probably a system there that is also not performing from an environmental perspective, in terms of occupant comfort. And for example, we saw a building, we assessed the building, we measured all the environmental parameters in it, and we also did a occupancy survey. And what it indicated was that the people found the environment to be stuffy, dry, and they felt that their productivity was impacted by as much as 30 or 40%. And what the actual environmental readings in the space showed that the relative humidity was below 30 in May, which is very low. Now, there wasn't any indications of drafts in the space, and what that basically told us was that there was a system somewhere that was cooling the air so much that it was pulling all the moisture out of the air. And because there's no drafts, it indicated that the system was also reheating the air. So you have a system heating and cooling the air detrimentally and resulting in an uncomfortable environment for people. It would also have a massive energy consumption as well. So by resolving the problem, you first of all reduce the energy consumption of the building significantly, but also you're solving a discomfort problem in the space, which will also impact on productivity. And the loss of revenue associated with the salaries of those people would outweigh any energy costs whatsoever. So by focusing on some of these problems, you are dealing with a number of other issues as well, which will pay for themselves. So it's about looking for the low-hanging fruit. The technology is there in relation to what we need to do to buildings. It's also thinking about how we go about doing these things. So as I said, for a new build, it's about putting less glass in, which is more expensive. So you're getting a cost saving from not putting the glass in, and then you're getting a much better energy performance from the building. So one compensates for the other.
Yeah. No, I think actually that was probably answers the second question as well, which was what's the likely capital cost impact on a development? But I think what you've said probably addresses that if you optimize design, you can save money elsewhere to offset some of the additional costs of trying to achieve net zero. The only thing I was going to add to what you said, Alan, which I think we've spoken about in the past, is, and this is probably maybe a bit more of a regionally specific observation. There's no doubt that the Middle East has come a very long way in the time that we've had a business here, which is just nearly 13 years now, or just over 13 years. And, I suppose global opinion of the Middle East was generates fossil fuel, has no real regard to energy consumption. And that wasn't particularly fair, but it was the perception. And in that time, there's been massive strides towards improvement in design, improvement in energy consumption, and reducing the demand on fossil fuel. And so these commitments that the various governments around the region are making is very positive. But what we're not seeing yet is so much of that actually filtering into design standards or, say, mandatory policy, for obtaining building permits. There are green building, so there's Estidama, which you have to comply with. Doesn't necessarily put as much emphasis as it could, perhaps, on carbon, or even set maybe targets that are as challenging. And I think one of the things you and I have spoken about quite a bit, Alan, is this whole thing around design standards. There's very generic standards that exist, whether it be, I'm not going to name any organizations, but there are organizations out there that we design buildings to. And the standards are quite generic, and they need greater consideration around the functionality of the building and how you can optimize. Because if you design to these generic standards, it reduces some of your ability to actually optimize the design and be more creative in the design. So, there are probably a couple of things I'd add to it.
No, you're absolutely right. I'm a firm believer in having very clear briefs for design teams. Nothing woolly and aspirational, because that can't be translated into something tangible. So if you want a low energy building, you've got to set targets for it. One number doesn't properly describe the function of the building, because it doesn't describe how it's occupied and density of people and so on. But what a low target does is it gets people to focus on the detail and look to try and achieve that target. And if they can't, then at least they can demonstrate why they aren't able to do it. And that applies to absolutely any aspect of the building itself. So you could be very clear about what you want the building to achieve. And some of the things, it's where you can't see what's happening is where the greatest problem is. And an example of that is infiltration. And I talked about the negative impact it has in terms of condensation inside buildings and mold growth, etc. And really, it's about quality of workmanship more than anything else. And if you've got two trades where one finishes, the next one starts, who's responsible for making that seal between the two elements? And if nobody takes responsibility, then it doesn't get done. By introducing air leakage testing means that something that's covered up will still leak. It'll cause a problem, and the contractor will have to go back and fix that problem at some point in time. So they may as well do it as part of their process, and that way there's nowhere to hide with it. And we had that in the UK, and the improvement it's made has been absolutely enormous, and it hasn't been properly recognized, the benefit that it's had in terms of the energy consumption of buildings. So buildings would have leakage of potentially 8-10 air changes, as opposed to now, which would be less than half an air change. So enormous amounts of energy was just getting out of the building. And the exact same principle is from this design for performance or neighbors type approach, where you set an energy target, you design the systems to achieve it, and then you're telling the contractor that they need to achieve it and that you're going to actually test it. Because normally a commissioning process, all it does is check to see whether the right amount of water or air arrives at the right location at the right temperature, and how much energy it's actually using to allow that process to happen is never considered properly. And the idea that you'd buy a car where you had no idea what miles per gallon it could do, and you'd no way of even finding out what the right level was, is just a nonsense. You wouldn't dream of buying a car like that. And going forward, it's going to be the same for buildings. So most, or rather a big chunk of energy improvement is about delivering the quality that a client has paid for. So you're not asking the contractor to do any more or spend any more money. You're simply asking them to manage the process and to deliver to the standard that the client is already paying for. It's not an extra cost. And in many ways, people, when they kind of hear me talking about these things, they kind of say, well, as an industry, aren't we already doing that? It's kind of common sense, but aren't we? Why aren't we doing these things? Because can we not deliver the quality that a client really thinks they're already paying for?
That's a good point. Rashad has asked a question as well, which is just picking up a bit more from the traction. He said, are there any specific sectors to target first to promote net zero, to encourage it and to get further traction?
I think commercial assets tend to be more professionally run, because they're valuable. You'll have facilities, organisations. They'll have metering set up for monitoring what tenants are doing and charging them and so on. So there's potentially more information in relation to benchmarking of buildings and knowing what kind of targets are appropriate for those buildings. And so I think the commercial sector is probably easier to get going on, and equally then investors are getting more astute in relation to being able to identify which assets are good investments from an environmental perspective. So again, there's more push in that in that sector. It does depend on the country that you're in, because it'll vary from country to country. And I know from my work in the UK that the education sector has been looking at schools for a number of years and how they might improve things there. And all the things I've described have been implemented since 2012, but they haven't been implemented terribly well, and contractors haven't been held to account. So it hasn't achieved those things, but it's changing, and it's changing quite rapidly. So I think you need to see how each sector is set up in each country and then go from there. But I think the commercial sector is probably the more obvious sector to start in.
Yeah, I mean, I'll just add one thing to that, Alan, and it's an initiative that already exists. But DEWA here in Dubai, they actually have an initiative where they're sharing consumption data with their customers. So when you get your bill now, you can see how much energy you've used in a month and how that compares to the average energy consumption and a high performing benchmark consumption. So they're trying to encourage people to improve their performance. And I guess it's volume, isn't it? You know, if you can tackle residents, then you're getting high volume. And as you say, Alan, if you're dealing with more professional organizations, they have the data. But it's all about encouragement. And I think that's a pretty good initiative to adopt, because I think the whole, you know, this whole climate emergency we're in and the publicity around it, I think people genuinely want to make a difference. I don't think there's very many people that just don't care. And I think that when you get utility organizations that share data with you to help you make choices, make good choices, and change your behaviors. I mean, you had it on one of your slides earlier, Alan, that behavior change actually makes quite a significant difference. And if we can actually get people just to change their behavior, whether they're at home, in the office, in a restaurant, in a shopping mall, then, you know, that's making big differences.
Absolutely. And the other aspect is by providing information, people can make rational decisions. So if they're spending their money and they're spending large amounts of it, they can decide that they want to cut back and just use things more efficiently. And particularly when it comes to wastage, because if you can reduce wastage, there's no impact on the operational or the comfort associated with that energy consumption. You just simply manage how you're doing things. And then for professional organizations, it's also about reputational damage, because we're seeing the whole kind of groundswell of protest against the climate emergency, and people want to be seen to be doing the right things. So by not taking the necessary steps to reduce carbon emissions, then people might choose then that they would invest in other organizations or go to other locations to buy their products, etc. So businesses need to be aware that they have to be seen to be taking the right steps forward.
Okay, that's great. So we're pretty much at the end of time. I think we've answered all of the questions raised. There haven't been any more come in since. So I'd just like to thank everybody that attended. I hope you found it interesting and inspiring, and let's all get stuck in to make this planet a better place. And I'd like to thank Alan for sparing the time to do this talk. Yeah, let's all keep up the good work in protecting our planet.
Thank you very much, and thank you for listening. And have a good day, and think about what the next steps are for you. Thank you very much.
Take care, everybody.